I think that I will have to introduce you, but it's okay.
I apologize.
Well, we are starting with the rounds of actual presentations. The first one is with Dr. Weiwen Chang, that he already presented himself. So he did a PhD position at Philipps University in Marburg here in Germany, and also a postdoc position in the same university. And now he's working at machine learning scientist group in Amazon, and he will talk about applying natural languages processing. We start.
Thank you. Hi, everyone. How are you? It's my pleasure today to present some projects we have in Amazon Berlin office. And I should mention that this is only a sample of projects, and we actually did a lot more. So Felix will present machine translation project, which is another big ARP project in Berlin. He will present shortly. And as always, that the project we mentioned here are a result of team effort. These are the members of ARP team in Berlin. And if you walk around and see any face matching these images, feel free to ask questions. So in this talk, I like to cover 4 different topics. The thing I've mentioned will roughly fit into these 4 different projects. We'll start talking about review moderation, where we try to purge the inappropriate and irrelevant reviews from the website. And then with the reviews online, we need to think about how to rank them properly. And then that is the review ranking project. And customer reviews are just a part of the customer contact we have in Amazon. And this Voice of Customer project, which is working on the customer contact, which is an internal tool, and try to analyze the contact from the customers. And then at the very end, I will try to talk about this X-ray project for Kindle eBooks, which go beyond the customer contacts. Now let's start with review moderation. You might have never write reviews at Amazon, but I'm pretty sure you read some. So reviews is critical to Amazon, and we receive every day tons of useful and helpful reviews from our customer. And some of the reviews, like the one shown here, are very funny and keep you reading. Unfortunately, that we do also sometimes receive submissions, which is not probably right to put it on the website. So here are some examples. For example, we don't allow spamming. And also, some reviews are seller feedback. We're talking about product reviews. So if you have comments about sellers, which doesn't belong to some product reviews. So the goal of review moderation is to select inappropriate and irrelevant reviews. And we try to help human moderators. And we take moderation very carefully. So that is, we try not to purge a review if we're not certain. Whenever we're not certain, we do send it to a human to make a final check. So we develop a set of internal solutions for analyzing customer reviews. And currently, it supports English, German, French, Spanish, Italian, and currently we're working on reviews for in Asian languages. So to be more precise, we're looking at 2 goals. So in terms of quality, we cast this problem as a classification problem. So we're looking at position and recall. As I mentioned, that we don't purge review easily. So apparently, this is a position-driven project, meaning that if we say we want to purge review, we must be very certain. And in terms of frugality and cost saving, we try to say we have a budget of human moderation, and we'll try to lower that level as much as we can. So in other words, position is the key, so we never sacrifice position for anything. And then depends on the business requirement, we trade off or we balance between the the budget of manual moderation and recall. So let's look a little bit on the sample data. So the ratio between the purge and the pull review is around 5 to 7%. And if we look among the reviews that are purged, so 3/4 of them are irrelevant reviews and 1/4 of them are improper reviews. So among the irrelevant reviews, so there are many of them are seller feedbacks, which doesn't belong to product reviews. So within the improper reviews, we have a lot of spams, and there are also a lot of reviews written in the wrong language. For example, you're in a US marketplace, but you write a review in Japanese or Chinese, that is not appropriate to put on site. Now I'd like to talk about some of the features we're using in this project. I should mention that many of the features we used here were also used for other ARP projects. So we're looking at lecture level features. So here is an example. There's a sentence. And then we'll look at unigrams, that is individual words in the sentence. We also look at diagrams. There's the two words, neighboring words. In this case, people continue, continue to, and to inquiry. Now we also look at things such as a token with part of speech diagram. Now in this case, for example, we have people continue, that is a noun with a continue, and then there's a people with a verb, and then continue with to, and there's a verb with to. So those are the lecture level features. We also look at character level features. That includes uppercase over letter ratio, Latin character over letter ratios, punctuation over text ratio, and so on. Moreover, we look at other text-based features. For example, the length of the review and what is the unique token ratio, things like that. So these features, together with character level features, are very helpful for example, determining spams. Now, of course, we have information go beyond the text information. So we're also looking at what is the review right to a product and what that particular product is. And we also look at some review information. Does this reviewer actually buy the product before writing the review, for example? So here is a high-level overview of the moderation system. So when you submit a review, it first goes through a set of rules. And those rules are mostly business-driven. For example, it depends on the marketplace. We might have a rule to determine if you write a foreign language to that marketplace, what we should do. Right? And depending on which rule is triggered, that the review can be either sent to manual moderation, be deleted directly, be purged, or pass over to the statistic classifier we train. And if everything passes, then the review will be approved and it will appear online. So we also build a reporting system which allowing us to monitor the moderation process in real time. So we can look at, for example, at any given moment, how many reviews are accepted, rejected, and how much human moderation we're using. So we launched the model for English back in July 2014. And that covers several marketplaces, including US, Canada, UK, India, Australia. And just recently, in March, we launched for EU languages. And the goal right now is really to reach a worldwide parity in moderation quality. As you may know, that the difficulty of an ARP project oftentimes depending on the languages. For small languages, due to the lack of resources such as labeled training data, it's oftentimes much harder to reach a better quality. Now, what we try to do is we really want to look into these small languages. We want to make sure it doesn't really matter where you're from, you're sharing the same customer experience with us. So that is about the review moderation project. So let's just say you submit a review, it passes the moderation. now it will appear online. So then the question is, how do we rank the review? How do we present the review on our website? This is the review ranking project. Let's say you want to shop for a product, a favorite book you want to find. I guess this book fit to the audience pretty well. So you found the book, and typically what you do is you scroll down and you look at the customer reviews, the product reviews. So here are some small things you might find interesting. I don't know how well you can see it. So here, the verified purchase, it means that the customer, the reviewer, actually bought the product before he wrote this review. And wine means that this reviewer received a free product in exchange of his or her review. We also have some statistics summarizing how many other customers like your review, think your review is helpful. So I think needless to say that ranking reviews is critical. Just like search result, so people normally don't look beyond the first page. The goal of review ranking is to promote helpful, trustworthy, timely, and diverse reviews to help customers and reach informed purchase decision quickly. To this end, we develop several algorithms, for example, for diversifying review ranking results to find the most representative reviews. We also develop models to predict the likelihood a review receiving a helpful vote at any given moment. Moreover, we have a model trying to model the reviewer's intent so that we can prevent untrustworthy reviews. So in the following, I will dive deeper into the first item, which is ranking diversification. So formally, we can define the ranking diversification in the following way. Let's say we're giving a product, and then there's a set of reviews. We try to find a subset of reviews with a size k, which is k corresponding to the top k, which is the first page, the position you have to position your reviews, that maximize certain utility. Now, a very straightforward ranking system, we simply choose a so-called additive utility function, right? Which means that the utility of a sum is equal to the sum of utility. But if you think about it, it doesn't always make sense. Right? So what additive utility means is that when you try to select a review, you don't really care about which reviews have been already selected, right? For example, if you look at a camera and you saw a review about the price of the camera, all else being equal, I think you probably prefer to see another review talking about something else, such as the photo quality, rather than reading another review about the price again. Right? So to capture that intuition, you can use submodular objectives. So with submodular objectives, what happens is that the utility of two reviews will be always bounded by the sum of individual utilities. So in other words, submodular objectives actually model a very fundamental economic principle, which is the law of diminishing return. And there are many different ways you can use in submodular objectives. And one of the most fundamental thing is probably maximum set coverage. So here is the formal definition. So we have a set of reviews, and each review is represented by a set of elements. The set of elements can be, for example, the content of the review and some other features of the review, for example. And the objective is to find a subset with size k that the number of covered elements are maximized. So intuitively, what that means is that it means that we try to maximize the content information given a budget constraint. So here, the content of information corresponds to the elements a review covered. And the budget corresponds to the value k, which is the free slot you have in your ranking. You can show formally that this objective is indeed submodular, and try to solving this exactly as NP-hard. There is the greedy cover heuristic provide a pretty decent approximation. Actually, you can show that under polynomial time, it is the best possible solution you can find. Illustration is in order. We here have reviews for the Philips clock radio. And on the left side, it is the old ranking. And then on the right side, it is the new ranking, which is after diversification process. So it is either to look at the reviews that are unique in the rankings. So on the left side, it is the third position, the third reviews. And the right side is the fifth reviews. Right? And it is denoted by the plus sign, which means the unique in that ranking. If you look closer, it's a little bit hard to say. This unique review in the left side are talking about the time set and alarm, which actually already covered in other reviews above and below it. And if you look at the unique reviews on the right side, they talk about the buttons of the radio, which is a new piece of information. So the diversification algorithm promotes this review to the top reviews. So as I said, in 2015, we proposed a set of algorithms trying to improve the review ranking. It is important to notice, however, that changing the review rankings is very challenging. First of all, the problem is counterfactual. In order to learn a new ranking, you need to gather training information. Basically, you need to collect historical customer behavior information. That information, by the way, is generated under the old ranking. Right? So that poses challenges in both training and evaluation. And second, reviews are so critical to Amazon, so there are multiple stakeholders. Besides customers, we have also sellers, also of the book, a manufacturer, last but not least, the top reviewers. So if you, for example, for a product, you have a 5-star review in the first position before, now your new algorithm put a 1-star review on the top, the seller won't be happy. And before you have a top reviewer's review on the first position, now you put it on the 5th position, and that top reviewer won't be happy. So there are many people involved in the process, so we should be really careful about it. And finally, maintaining customers' expectation of a good review is pretty hard. No matter how complicated your algorithm is, you should not confuse the customer. So at the end of the day, the customer should have a good notion what a good review is. So that poses challenges not only to the modeling process, but also to the UI design. So let's look at the review. These are the reviews for that book. This is the actual current review on the website. And as a comparison, this is a review from back in 2013. There are two interesting changes I want to point it out. So first, we stopped calling it most helpful customer reviews anymore. Now it's simply top customer reviews. The reason is that we try to avoid to give the impression that the ranking of the reviews are dictated by helpful votes. And we also reveal less information about the votes in the new design. We put the statistics to the bottom of the review. So all this belongs to the efforts, the UI efforts trying to maintain expectation of our customer. Now let's talk about Voice of Customer project. It is an ongoing project, so I don't really have much result to show, but I'd like to show you some ideas behind it. The goal of this project is to enable users in an analyst role, such as a product manager or a seller, to understand and react to larger volume of customer feedback in real time. So customer feedback is a broader concept than customer reviews, including some other contents as well, such as the email from customer and Q&A from customers, for example. And the applications are to help a user, the seller and the product manager, to make decisions regarding their products, and also enable us to better understand our customers. So there are two directions of this project. The first is sentiment extraction. So for sentiment extraction, we really try to understand fine-grained segments, such as the sentence or aspects, the sentiment on that level. It is important because even very helpful positive reviews contain negative sentence or aspects. While doing sentiment analysis on sentence level is simpler, doing aspect-based sentiment analysis is very hard, because you need to know what are the good aspects for a particular product. And for example, for a camera, a good aspect may be the price, the weight, and the photo quality. So the idea really is we try to use whatever information we have at hand, such as existing taxonomy or query logs, and we use that information as much as we can, and we go from there. And eventually, we probably even need to do some unsupervised learning to mine the topics or aspects. And also, when you consider all the products on Amazon, it is impossible to have sufficient label data at all granularity. So we really need to, and we have to, exploit some other signals. So this poses challenges in both data acquisition and also modeling part. A second direction of this project is we call trend analysis. The idea really is we try to know what the customer context is about regarding a product. So there we are using text summarization techniques. So we try to give a good overview to our users, so the like PM, like product manager and sellers, they don't have to go through each individual customer reviews. And also we need to notice that the customer context come in online fashion, they come continuously. So we need to know what are emergent topics among the customer context. So all this pose challenges in many different factors. For example, it is challenging, for example, to think about how can we visualize the result to the customer. And also from the modeling perspective, how do we control the computational complexity, because we have such a huge amount of data. And moreover, as I mentioned, that we have more than simple text. Right? We also want to make use other information, such as, for example, the star rating review and the customer information, and so on. So here is a related feature, which I think probably giving a better flavor about the project. This is called a reason to buy feature. Now here, for a camera, we have this minded topics, or say aspects. And this particular example is video quality. And under this topic, we show all the associated reviews. And with the part highlighted, which is referring to that particular aspect. Okay, so much for customer contact. Now let's talk about ebooks. I'd like to talk about the X-ray project for Kindle ebooks. So the goal of this project, simply put, is to enrich Kindle reading experience. I don't know how many of you know this X-ray feature on Kindle. I think it's a very useful feature. Whenever I'm reading a big book, such as Harry Potter, I always get confused in the middle of the book about all the names. And what X-ray does is it automatically lists all the characters in the book. And when you collect that name in the book, it will tell you who it is, and it also tells you where it appears in the book. In 2014 and 15, we built statistic models, in-house models, to discover names in books in English, German, and Japanese using named entity recognition technique. And we also have a model to combine multiple mentions of a single entity. For example, Jaime Lannister, Jaime Kingslayer, within the same book, are very likely talking about the same entity, and we group them together. We also built a method to discover family relation between entities in the book. So here is a typical family relation graph based on Harry Potter. Customer and readers love this, and the fan like look at this. So the idea really is we try to build that graph, that family graph, based on the text and do it automatically. And don't worry about spoilers. Because on Kindle, we know your reading progress. So we can reveal the information according to your reading progress. So this is like high-level approach for this problem. So basically, we first do some pre-processing. We normalize the text. And then we select sentences which is highly likely to contain family relations. And then we have two tasks. The first, we try to predict the relation between entities. So for example, when you get a book and test, you might find out that Tywin Lannister is a sibling to Cersei and Jaime Lannister. So after this step, we have an initial graph. And the second task is to minimize the consistent cycles while preserving highly scored relations. So for example, after doing the process, you find out you're pretty certain that Tywin is indeed a sibling of Jaime and Cersei. It is then impossible for you to say that Cersei is a parent of Jaime. I see some. Here is an actual example on the Harry Potter book. As you can see, that the result actually is pretty good. So here is the example that we found out these two entities are husband and wife. And then we also have a relation which we predict that it's probably the uncle of this entity. But then during the pruning process, we delete this age because the value is low. So this basically gives an idea that what the end result might look like. So that's the very last slide of my talk. So in this talk, I talk about review moderation, review ranking, and the voice of customer data analytics, and X-ray for Kindle ebooks. Though I have to say again that this is only a sample of the project we're doing here in Berlin. And if you have any questions, please feel free to talk with us. So that's all from my side. Thank you very much.
Any questions?
When you outlined your process for selecting which reviews to show to customers and how to rank them, please correct me if I'm wrong, but I got the impression you have this two-step process where you first sort of try to select a maximally covering case set of reviews with respect to topics, and then you look at the problem of ranking them. Is there some reason why you don't do both at once? Like you essentially say, look, I'm going to take not a set, I'm just going to take a list of reviews, and then I'm going to look at a utility function that works on the well-ordered lists instead. Is it just for computational reasons, or because that doesn't work with the data you have?
Yeah, so that's a very good point. Let me just go back to that slide. First, let me say that there are many different ways to do that.
So why are you doing it the way you are?
And one of the processes, what we're doing right now, is that we already have a ranking which is presented as an existing ranking algorithm, which is already pretty good and trying to maximize certain kind of utility. Right? We oftentimes think about the deprecation process as a post-processing step. We apply this procedure on top of another ranking procedure. And there are multiple considerations. Even though that I show that there is some heuristic, which you can do this deprecation in the point of time, but still it's quite costly. So that's why we're trying to constrain the computational capacity as much as I can. So doing as a procedure as I described, you can basically control what's the input to the deprecation step. For example, you don't have to give the whole list of review to this second step. You can only give, for example, the top 20 or top 30 reviews. So that's the reason behind it.
You spoke about this review moderation stuff, and you have these deterministic rules and then these statistical rules to discard reviews.
Yeah.
How do you go about kind of calibrating each of those?
That's a very good question. So for the rules, we normally have been it's mostly business driven. So there are clear business objective, and we, as a model perspective, we assume that's correct. So the turning process we do is mostly on the statistical part. But of course, at the end of the day, when you have the whole system, you of course can audit the whole process and look at the overall performance of the system. So that's probably answer the question.
What kind of drivers, in terms of the business part of that? Like, give an example.
There are many different rules. For example, we might look at, the one thing I mentioned is that if you have a marketplaces, English marketplaces, and you write a review in different languages, we might have different rules to do, depends on what you're writing.
Very nice talk. For review diversification, have you thought to use any topic modeling instead of doing this aspect in the way that you do it? You can just apply a topic model and then just choose.
So I assume you're talking about this trend analysis project on this Voice of Customer project. Oh yes, we do consider topic modeling. This is something we definitely consider. So I think it's a very good tool that can basically building the different aspect of the document you have. So we're looking at that. So this is the answer to your question. So of course there are also challenges in that. For example, as I mentioned that visualization of the topic you mine is always a challenging. Right? And it might make sense to you and me, but for end customer, like people who is not in a tech role, it might be challenging that you don't want to confuse them. So even though it is an extremely nice tool, but in practice there's still a lot of challenges.
Any questions?
Yes. So one would be, how do you set the value of K, the number of topics that you want to list? Because presumably if these guys interact strongly, showing 3 might be a very different solution from showing 5, say.
I see.
And the other is for to address the counterfactual issue that you mentioned. Do you guys do some kind of randomized experiments where for different customers you show them different configurations of reviews and then see which configuration is better? Because you could certainly do some design of experiments basically.
To answer your first question, so to select what is the optimal K, that is a lot of consideration. Computation is one, but of course also depends on the platform, right? So even for the same product, nowadays you go to the website, it might show a different number of reviews on a desktop rather than in a mobile phone. So there are a lot of consideration there. And the second question, could you elaborate that? I didn't.
So say designing experiments, right? Yeah. So not just rely on the data you're collecting for a given ranking system, but actually randomly say show different configurations and see which works better, sort of guide your. Yeah.
So I think that a technology, a technique which relates to what you're talking about is A/B testing, which I think most major companies doing A/B testing. So this is definitely something we're looking at. We should also notice that even doing A/B testing, it doesn't change the fact that, for example, re-ranking, the problem you solve is counterfactual. Right? What data you collect, the model you build, are still based on the data you collected in the past. And you can do A/B testing, then collect different data, but the scope and the amount of data you can collect cannot really compare with the data you have in there. But you're absolutely right. So A/B testing is a powerful tool that we're using.
Any more questions? If not, we thank again the speaker.